Suppose an object is shot straight upward with an initial velocity of 50 meters per second at a height of 100 meters. So I'll do 4 questions, then I'll be all for this video. How fast is the object going at A, 1 second, B, 5 seconds, C, at, I don't need the word at, I had it in question, its highest point, and D, how fast is the object going at impact with the ground. By the way, I used to get confused on this last part. When it hits the ground, I always said it was 0 meters per second because it's sitting around, but that's not what we're looking for. How fast is the object going at the moment of impact? It is traveling at that moment. How fast is it going? So let's go ahead and write up a solution to this. As I said before, I'm not going to bother much with the computational aspects like I did in the last problem. I'm going to solve one problem. I'm going to get a formula for the velocity, and then I'll plug in each of these different things there. So first, what's the formula? It looks like this. The height of the object is S of t equals negative 4.9 t squared. Now it was shot up at an initial velocity of 50 meters per second. So since it was shot upward, that means that we have a plus 50t in here. By the way, in this course we will determine this formula. We'll show you how to create such a formula like this, but right now I'm just going to give it to you. It was also shot at a height of 100 meters. In another way, suppose if it were shot downward, then the middle term, this 50t, would be negative 50t. And if it were somehow shot from below Earth level, this 100 would be a negative. Anyways, let me have a formula for the velocity. So, to find we're finding the instantaneous velocity, so let me remind you of that. So to find the instantaneous velocity at any time t equals a, we must compute the derivative of s of t. You remember the formula for this, s prime of a, this is the velocity at any time a, is given by the limit as t goes to a, s of t minus s of a all over t minus a. Now what I'm going to do next is plug in the relevant formulas. So limit as t goes to a. S of t, negative 4.9 t squared plus 50t plus 100 minus s of a. Don't forget to put in parentheses or you'll get the signs all messed up. Negative 4.9 a squared plus 50t, well 50a plus 100. All of this is over t minus a. Now I'm going to do some simplifying in the numerator. I'll have negative 4.9 t squared plus 50t. Notice that the hundreds cancel out, so I'm not going to include them. Plus 4.9a squared minus 50a all over t minus a. Now, you're guaranteed that a is going to be a 0 in the numerator. So what I'm going to do is rearrange this and then factor. So I'll get the t squared and the a squared together, negative 4.9 t squared plus 4.9 a squared plus 50t minus 50a. All of that divided by t minus a. Of course, this is the limit as t goes to a. What I'm going to do with the first two terms is I'm going to factor out a negative 4.9. What that will leave in its wake is t squared minus a squared. Similarly, from the other two terms, I'm going to factor out a 50. I get plus 50 times t minus a over t minus a. Now, in that t squared minus a squared, you should notice that it factors because the difference of squares. So I'll go ahead and factor it. So I have negative 4.9. This will factor as t minus a times t plus a. And then I have plus 50 times t minus a. All of that is over t minus a. Now, if you notice in the numerator, I have t minus a is attached to both pieces, if you allow me to call it that. So I'm going to factor out a t minus a from the entire numerator. So I'll have a t minus a out front, and then inside the parentheses, I'll have negative 4.9 times t plus a plus 50. End the parenthesis, and all of that is over t minus a. Now I can take out the t minus a. Good. Now I'm left with the spot where I can plug in t equals a. Just to be a little more clear, I'm going to rewrite this thing because I have a feeling it may be a little complicated if I try to jump steps. So I'll go t plus a. So negative 4.9 times the quantity t plus a plus 50. Now I'm going to go ahead and replace t with a. So I end up with negative 4.9 times a plus 50. And that equals negative 4.9 times 2a plus 50. And just to make it as simple a formula as I possibly can, I'll multiply the 4.9 times 2, so I get negative 9.8a plus 50. So that's my velocity. In fact, if I want to, this is s prime of a. I could say v of a, because I'm talking about the velocity. V of a equals negative 9.8a plus 50. Or what's even better is that a is annoying because it's not a variable that I'm using throughout the problem. T is the variable. So instead, I'm just going to replace a with t and write v of t equals negative 9.8 t plus 50. You can use whatever letter you want. I just prefer t because it does mean time. Now, I had some problems. Part 1 was when t equals 1 second. What's the velocity? So I'll take v and put a 1 in for t, and I get negative 9.8 times 1 plus 50. And this will equal negative 9.8 plus 50, which equals 40.2. And don't forget now your meters per second. Notice that it's positive, meaning the object is still going upward at 1 second. Part B was 5 seconds. T equals 5 seconds. So I'll do V of 5 equals negative 9.8 times 5 plus 50. And that equals negative 49 plus 50, which equals 1 meter per second. So it's still climbing even at 5 seconds. Now let me see what was part C. I don't remember the original question. Part C was at its highest point, and the impact with the ground is part D. So part C is its highest point. Well, this is an interesting question because you should know that when the object gets to its highest point, it is neither climbing nor falling. So therefore, the velocity is 0 meters per second. However, just to prove to you all this calculus stuff works, I'm going to consider the graph consider the original function s of t was equal to negative 4.9 t squared plus 50 t plus 100. That's nothing more than a parabola. So what I'm going to do, let me real quick graph this thing. And let me go into y equals, that's close to what I want actually, negative 4.9x squared. Remember, you got to use x instead of t. So I have plus 50x plus 100. A little slow on the uptake there. If I do zoom 6, I'm probably not going to see this graph, maybe not at all. Let's see what happens here. I see a little bit of one. But that's not much for me. So what you can either do here is zoom out, or even better, if I trace, it'll start me at 0, 100. So I see that my y values need to at least be 100. As I increase, I can see as x grows bigger, y is getting bigger and bigger and bigger. Maybe I'll have a good chance if I set my window in this way. Let's keep x min. I don't need x less than 0 because that stands for when it starts. 0 seconds is when it starts. Negative time doesn't have any real meaning in this problem. But the y values, I know I need to go high with these. So I'll leave y equals negative 10. I like a little buffer at the bottom. But for y max, I'm going to set it to 200. Let's graph this again and see what we got. I've almost got it. And I see that I need more x value too because the graph does run off the screen. So as my next shot for the window, I'm going to change my x max to 20 and my y max to 250 just to see if I've got it. And graph that. Gotcha. Your calculator has quite an ability here. If you go second calc, you can actually find the maximum by going to number 4 here. It says maximum. So I'm going to hit 4. Now, you'll see on the screen it says left bound. That means they want you to move the cursor on the screen to the left of the highest point. So I'll go a little bit to the left and I'll hit enter. And then it wants a right bound, so now you move the other direction. Make sure you move past the highest point and you're to the right of that highest point. Hit enter. And a guess means it's somewhere in between. Your calculator is using some sort of an algorithm that requires you, didn't mean to do that. Back to my graph. I got to redo it. Okay, so second calc 4. Same thing. Yeah, maybe you weren't following, so you get a second shot. Enter. That's my left bound. There's my right bound. It really doesn't matter, just so long as the left is to the left and the right is to the right. And then some point in between. The calculator is using some sort of an algorithm where you've got to hone it down a little bit for it. And so what it does is it gives me the maximum occurs when x is 5.10204441. So let me pop over there. So in fact, I think that's not a bad idea to take this. Let's go ahead and copy it. So the highest point occurs when t equals 5.1020441. So highest point occurs when t equals, I'll use a lot of decimal places, just I'm going to check this out later, 5.10204441. Now what I'm going to do is plug that into the velocity formula, which was negative 9.8 t plus 50. So v of 5.10204441 equals negative 9.8 times 50 plus 100. That was a mistake. And so let me move the 100 out of the way. 5.10204441 plus 50. Best to use a calculator for this, I think. So I'll go to my home screen for this. Negative 9.8 times 5.10204441 plus 50. This number that it outputs here, this negative 3.218 e negative 5, you have to read this as this e negative 5 means you move the decimal to the left 5 places. So what this really means is negative 0.403218. You can see within calculator error that's trying to tell you that it's 0 meters per second. So you can see the velocity formula does work. That was real computation there. For the last one, when it impacts the ground. Now you can do this numerically on the calculator and find the x-intercept for when it comes back down. And by the way, the object does not follow a parabola. Remember, the object is just going straight up and straight down. This is just a mathematical model where the x-axis is replaced by t and the y-axis is replaced by s. That's all it is. Anyways, you can find the right x-intercept will tell you when it impacts the ground. But I think it's not a bad idea to remind you of some algebra, quadratic formula, etc. So I'm going to do negative 4.9 t squared plus 50t plus 100 equals 0. The quadratic formula comes into use here. I would probably, if I could, I would simplify this, but I don't think I can do much with it, so let me just go straight to the formula. T equals negative b, so I'll have negative 50. The b, a, b, and c's I'm using come from the formula. Plus and minus the square root of 50 squared minus 4. A is negative 4.9. And C is 100. All of that is over 2 times A. I don't know how much I'm going to do by hand. If it comes out to be not such a bad number, then fine. Let's see what happens here. I have negative 50 plus and minus. So part of this is to help you with some of your algebra. You need to develop really good algebra skills in order to do calculus. There's just too many things that require hefty computations. And this is nowhere compared to what the hardest stuff you're going to have. 50 squared is 2,500. The two negatives cancel. In here, I'm going to get 400 times 4.9. 400 times 5 would be 2,000, but that's 4.9. So 400 times 0.1 is 40. So 1,960. I bet I'm going to have to check that. I don't feel very comfortable about that. The bottom is negative 9.8. Students oftentimes have trouble with simplifying this. Now, you're going to have a plus and minus no matter what happens. I'm going to clear the negative in the denominator by multiplying it by negative 1, and I'll do the same to the numerator. My new answers will look like this: 50 plus and minus. You could write it as minus and plus just to indicate that you've done something with it, but you don't have to. Okay, so then we have 4460 in the square root, 50 plus and minus 4460 all over 9.8. And if you want to go to the calculator or not, it's fine. You just fast forward through this, whatever. The 4460, I know I can take a 4 out of that. That'd be 4 times 1115. When you bring out the 4, it comes out as a 2. But I'm not really sure what else I can do with it other than that. Not off the top of my head. I can try to see if things go into it. But I don't think I want to do much more to it than that. Now notice you have two answers here. You have 50 plus 2 radical 1115 over 9.8. And you have 50 minus 2 radical 1115 over 9.8. Those get rid of this one over here. The second one will be negative. That corresponds to the left x-intercept. This is the one we want. That's the thing we want to plug into the velocity. And actually, if you remember, the velocity, let me come back to it for a second. Where did it go? Where's my formula? The velocity is negative 9.8 t plus 50. So v of t is negative 9.8 t plus 50. And then so v of, I'm actually going to plug that stuff in there. I'm going to have 50 plus 2 radical 1115 all over 9.8. That equals negative 9.8 times 50 plus 2 radical 1115 over 9.8 plus 50. Check this out. The 9.8's cancel. And then I have a negative. What I have left then is negative 50 minus 2 radical 1115 plus 50. Notice that the 50's cancel, and I'm left with negative 2 radical 1115 meters per second. So now I'll go and figure out what value that is on the calculator. And if you want, actually it might be easier to do it this way. Let me go back on. let me go back to the graph. And let me go, if you go back into calc, check this out. You can find the 0, that's number 2. Now what you do is the same thing as before. You give it a left bound, so you pick some number to the left. You know that's to the left of the intercept. Got it? Now I'll pick a right bound. What you're trying to do is trap it in between there. I hope the graph moves for me, but I can look at the y values and I can see that they're negative, so I know I'm to the right. And then some value in between, I'll just try to get whatever, anything, and enter and see what it tells me. It tells me I have 11.916656. So let's see if that number jives with this number. Remember that, 11.917. What I wanted, the number that I should have plugged in was this one. That's the one my calculator should tell me. This is the velocity, but the time it hits is this. So I'm going to make sure that jives with my calculator's value of 11 point something. So let's take a look at that. We'll take 50 plus 2 times the square root of 1115. Let me hit enter. Gives me 116 point some stuff divided by 9.8. Enter. And there's my 11.917. So I confused myself by doing that stuff. So here you go. This is how fast it's going as it hits the ground. If you want the decimal version of that, you can easily get it on the calculator. I showed you already. It was it's going about negative 66.783, approximately negative 66.783 meters per second. Negative is because the object is going downward. So that's the only example I want to do here. We'll do probably some more examples from a more algebraic standpoint next time.